Welcome students, welcome to Spark Academy. My name is Nityanand Ghosh. I am faculty here. So basically physics faculty here. Basically I will be discussing the important topics which are covered under NEET exam, your medical entrance exam. What are the important topics of physics that are covered? More detailing will be done when the actual the subject topics will be taught in detail. So the formulas associated with that particular topic will be discussed. So first the important topics for NEET exam. Physics. So as you know, physics is a Greek term. It is called nature actually. Study of nature is nothing but physics. You have so many laws, Newton's laws, Kepler's laws, and so many laws are there in magnetism, in electrostatics and all. So many laws are there. So the main topics covered under this NEET exam is, let's say first topic is mechanics. See, under mechanics you have to know the fundamental equation of motion, motion along a straight line, and then motion at some angle, that is the projectile motion. Then you have to study work, power, energy, motion in a straight line, motion in straight line, all those use of those equations what you have studied. V is equal to U plus AT, V square minus CU square is equal to 2AS. Then Sn is equal to U plus A by 2 into 2n minus 1. S is equal to ut plus half a t square, and then under gravity that A will be replaced by G. All those things actually you have to know. What is the, suppose if I throw a object up at maximum height, what is the time taken to reach maximum height, and then total time of flight. Then in this projectile motion will come. Projectile motion will come, and then you have to clearly know, before all this you have to know the difference between scalar and vector quantity. Scalar and vector quantity you have to know with example, because some things are very confusing. See, work, for example, I will explain what is a scalar quantity and vector quantity. Scalar quantity has got only magnitude, vector quantity has magnitude as well as direction. But there is a confusion. Some of the some of the quantity, for example, work is equal to force F dot S. So these two are vectors. Still work is a scalar quantity. So dot product of two vectors will be a scalar, and there are examples pertaining to this. So you have to clearly know what is the difference between scalar quantity, vector quantity, and then units of all physical quantities you have to know. Physical quantities you have to know. Physical quantities means so many umpty number of physical quantities is there. Your velocity, acceleration, work, torque, angular momentum, linear momentum, and dielectric constant, and let's say your force constant, viscosity, surface tension, inductance, capacitance, everywhere there will be units as well as dimension. And in competitive exam, mostly what they are asking is, they may ask which two physical quantity have, which which I mean two physical quantity which the same physical quantity has got two different units. Same physical quantity, two different units. For example, if I say electric field E, electric field is force per unit charge. Force acting per whenever you bring a charge, the force required to assemble a charge, force divided by the test charge will give you the electric field. So what is its unit? Newton per coulomb. Same force, another formula is there, V by D. V by D will be volt per meter. So same physical quantity and you have got two different units. Another example is there, let's say force constant, F is equal to minus kx. In simple harmonic motion, you have got force constant K. K is equal to force by x. So Newton per meter. This is force constant and surface tension. Surface tension also, it is force acting per unit length on the membrane of liquid. Okay, so this is also Newton per meter. So two different quantities having the same unit. Like these questions also are asked in the exam. So you have to be very careful. Okay. So now see, this is same physical quantity having two different units, and here two different units, two different physical quantity having the same unit. So this type of questions will be sometimes asked in multiple choice. So anyhow, so mechanics, motion in straight line, projectile motion, and then you have work power energy. Work power energy. Okay. Work power energy. Work power energy. So all work under work, some problem will be asked, power and then energy, kinetic energy, potential energy, and then work energy theorem. Work energy theorem. This is very, very important for exam. Very, very important. You know, under work energy theorem, every year they will be asking questions. And then it also has your planetary motion, gravitation chapter. Gravitation chapter. You know, two bodies will attract, you know, with a force. Then what are the laws associated with it? And then your all Kepler's laws, planetary motion, first law, second law, third law. And under gravitation, you know how the satellite are sent to space, what is the velocity of at some time t of when you send a satellite, what is the velocity after a time t. All those direct formulas are there that you have to know. Kepler's laws and geostationary satellite, all those things you have to know under this. This is what is actually gravitation. Topics covered under mechanics. Then second topic is your electrodynamics. First let me write down the topic, then I will electrodynamics. Dynamics. Third topic is actually modern physics. Modern physics. Fourth topic is nothing but your optics. Fifth topic is nothing but thermodynamics. Thermodynamics. And sixth topic is waves and oscillations. Oscillations. So under electrodynamics, what are the topics will be discussed? Your let's say electrostatics. Electrostatics. Under electrostatics, you know the charges are at rest. Your Coulomb's law, Gauss's theorem, how you, when a charge is there, how you find out electric field at some distance, and what is the electric field because of a charge sphere or a charge cylinder, or there will be infinite length charge, what is the electric field at some point. Similarly, potential, this also carries capacitance, capacitor ka all logic, what is the energy stored in a capacitor, how you assemble a group of capacitor, your series connection, parallel connection, then combine connection, then what is the energy, you know that capacitor stores electric potential energy, then you have to know all those things. And sometime you know, in a circuit they will be asking you about what is equivalent capacitance, and all those things will be asked under, and also potential also will be covered under, potential also will be covered under this electrodynamics. Under electrostatic, this is the thing which is covered. Then you have got you have got current electricity. Current electricity, it is the dynamic part. Electricity, it is the dynamic. Charge starts moving. You know, whenever the charge is at rest, there will be electric field associated with it. Electric field is the field around a charge within which its influence can be felt. So charge at rest will give electric field. The same charge, when it is moving, it will give rise to current. Current produces magnetic field. So charge in motion will produce electromagnetic field. Electromagnetic wave we call now, electric and magnetic field. So current electricity, in that all those laws you will be writing, your Ohm's law, Kirchhoff's laws, and all those meter bridge condition, your Wheatstone bridge, meter bridge, potentiometer, Wheatstone bridge condition, that P by Q, R by S, that derivation, you know, their unequal bridge balancing will be asked in the exam. So there will be branching current, I1, I2, I3, I4, like that. Branching current will be there, but if P by Q is not equal to R by S, they will be asking you about the branching current. Either this side branch or this side branch. There will be, like this branch will be there, no? So all those Kirchhoff's laws and all those things will be asked under current and electricity. Then you have got magnetism. Whole branch of magnetism will be there up to your electromagnetic magnetism. Different types of magnetic material will be there. What are the magnetic effects when the magnet is broken into some pieces? What will be the resultant magnetic field, torque, and to North Pole, South Pole will attract. So what is the force governing it? All those things will be different type of magnetic material are there. No, dia, para, ferro, ferri, ferrites. So many types of magnetic materials will be there. Some questions will be asked from those particular topic. And then you have got electromagnetic induction. Electromagnetic induction. See, electromagnetic induction, first, you know, Oersted, Ampere, Biot and Seward, they said that whenever there is a current carrying conductor, there will be magnetic field associated with it. And the reverse been actually proved by Faraday. So Faraday, from magnetic field you can get, if there is a change in magnetic